Okay, here we go. All right, so number 8, right, we're trying to solve these, but notice that we have the distributive property here that we need to use. One thing that happens a lot of times on the final exam is that people forget that that negative that's in front of that 2 has to carry with it. So you're not just distributing a 2 here, you're distributing a negative 2, right? So when we distribute that through, so I'm just going to rewrite that over here, that'll say 6 plus 3x minus 2 equals 7x. And then negative 2 times 2x is negative 4x. And then negative 2 times negative 8 is positive 16. Okay. And now we see we have x's on both sides of the equal sign, so we actually need to get the x's on one side, whole numbers on the other side. But before we do that, let's get the like terms together. So when we did this first one, remember I said some students like to put like a little line down where the equal sign is, just to help them know, am I combining like terms or am I doing the opposite operation because I'm moving it over from one side. Remember, if you're moving something from one side of this line to the other, then you have to do the opposite operation. But we'll see, like here we got 6 minus 2, and they're both on the same side of the equal sign, so I'm just combining those together. So 6 minus 2 gives me 4, and then 3x doesn't have anybody to combine with. Right, equals, and on the other side I can see I have my 7x and a negative 4x that I need to combine together. 7x minus 4x is 3x and plus 16. Right, and now this is where I'm going to start moving things over from one side to the other. Right, if I subtract my 4 right here on this side, because I'm trying to move it over to the other side, right, that's going to give me 3x equals 3x plus 12. And then I need to get my x's together, so I'm going to subtract my 3x over to the other side. Well, these x's actually end up going away on this one, right? And so then I'm left with 0 equals 12. And that's not a true statement. So remember I said when we come up with something like this, we'd say our answer is D and E, right? Does not exist or no solution. So we'd have here for that answer. Okay. Questions on that one?
You just type no solution, or won't it make us do D and E? I forget.
Yeah, so on the final exam, remember it's going to be just like your Canvas quizzes. And so how have you had to enter those in on the Canvas quizzes? Do you remember?
I know most of them have been D and E, but I don't know why, but I feel like I entered no solution before for one that's a D and E, and it said it was like right, but
yeah,
I honestly don't even trust my memory.
Yeah, and usually it'll tell you right on there, like, you know, it'll say, you know, what to put in if there is no solution. So you'll see that. But usually on this it's been D and E, I would say, for most of the, you know, most times. So that's probably what they'll want on the final also. Okay. All right, and let's look at maybe one of these ones with the fractions, right? Does anybody have a preference whether we look at 9 or 10? Does either of those look like? I mean, or we can do both if you're feeling really worried about fractions. But
let's do 9.
Okay, let's do number 9. So 9 says 1/4 y minus 3 equals 1/7 y. Okay, so remember when you have fractions, it's going to be easiest if you can eliminate the denominator, right? You can kill off that denominator by multiplying by the LCD. So remember I said for sometimes it's nice to put a 1 underneath there, so you're looking at all of the denominators. And then when you're deciding, right, your LCD, then you are saying, okay, 4, 1, and 7. Well, the LCD of that is actually going to be just 4 and 7 multiplied together, which is 28. And we talked about how you can always do that to be a common denominator. It might not always be your least, but that's okay. Right? And then I'm going to multiply each part by 28 so that I can kill off the denominators. Right? So let me do that here. Right? So I'm going to multiply each part here by 28. And so now I can see, all right, 4 divides into itself once and into 28 7 times. Right? There's nothing on the bottom there to divide out, so I'm just going to end up multiplying those two numbers together. But on my last one, 7 divides into 28 4 times. All right, so let's simplify this up so we can make sure we know what it has. All right, so on the top we have 7 times 1 times y, so that's going to be 7y. All right, 28 times 3, what is that? Is 84. And remember, there was a subtraction sign there, so don't forget about your minus 84. And then on after the equal sign, we have 4 times 1 times y, which is 4y. All right, and now we look at that and say, oh, I can totally do that. I can solve that, right, because we don't have denominators. We killed them off, right? And so now I want to get my y's on one side, whole numbers on the other side. So I'll subtract my 7y over. So I have negative 84 equals negative 3y. And then I just need to divide by negative 3. Right? So negative 84 divided by negative 3 is going to give us 28. Right? And that's kind of what up there. I did that all right. Positive 28. Hey, questions on that one that you want to look at? Do you want to do the other one with the, why don't we have you try this? I want everybody to try number 10 on their own. That way you can give you a little bit of chance to see what you can do on your own or if you're going to get stuck. Okay, so everybody now try number 10 on your own. So I came up with 5/14 for my answer on there. And a lot of times when you do start off with fractions in your equation, you will end up with a fraction in your answer. And so just kind of keep that in mind. On the last one we did, it worked out nicely, but oftentimes they just still work out with fractions in them. But it's nice to kill off the denominators, because notice you don't have to, like the very last step is where you get that fraction. Otherwise, when we talked about this before, we said you could get a common denominator with everything, but then you have to work through the whole problem with that common denominator, remembering your, add and subtract rules, multiply and divide rules when it comes to fractions. So it just makes it a lot less mistakes, I would say, happen if people kill the denominators. Okay. You raise your hands, like use the hand raise button if you were able to come up with 5/14 on that. See if you're able to come up with that. Awesome. Remember the hand raise button, if you've forgotten where it is, sometimes you have to like scroll along the top and a drop down will come up, and then there's that participants thing that you need to click on so that you can get to that hand raise button. Alright, so the fraction ones are definitely ones that students like to review over, because they tend to be, well, and they do oftentimes show up on the final exam. They're, they want to make sure that you know how to work with fractions in equations and stuff too. Okay, so what about 11 or 12? Would you like to work through either of those? Those have some fractions in them, but now they're proportions. Anybody have any suggestions, or want to do what you think is going to be best for you? What's going to help you the most?
Let's do 12.
Okay, let's do number 12. All right, so 12, we have a proportion, which means we have one fraction equal to another fraction. So remember we said when we have that, when there's just one fraction on one side, another fraction on the other side, we can do what's called cross multiplication, right? So I can take the diagonal of 1, right? So that would be 7 times x plus 3, right? So I'm multiplying that diagonal together, and I'm putting it equal to the other diagonal, the 8 times x minus 9. And you've got to make sure that you put it in parentheses, because you're doing 7 times all of that stuff inside and 8 times all of the stuff inside there. Okay, so make sure you have those in parentheses, because now we've got to distribute that through. So that gives me 7x plus 21 equals 8x minus 72. I'm just distributing those through. Now I want to get my x's on one side and whole numbers on the other side. So I'm going to choose to subtract my 7x over this way. You could have moved it either direction. That was just my choice. So I have just x left on this side, right? Got 21 equals x minus 72. So now I need to move that 72 over on the other side to get x by itself. So we need to add the 72 over. And so we get x equals 93 on that one. Okay. Questions on that? How to solve those proportions? Remember, that only works if we have one fraction equal to another fraction. So let me just go back up here and make sure it's clear. Like, we couldn't do proportions on 9 or 10, because notice we have a fraction plus something equals a fraction. Right? It has to be a fraction equals a fraction in order to do this cross multiply. Okay? And maybe I'll just put cross multiply there next to it so you remember that's what we did on this. Okay. All right. And then we have some with some decimals also. Oftentimes people don't get too freaked out by those. You can use your calculator and everything, right, on these. Just make sure that you're just being really careful with this as you're distributing those through, but it still should be pretty good. Maybe let's look through, let's look at number 14. I'll do it over here. Okay, so this one says 0.25 and then parenthesis x plus 50 minus 0.03 times x minus 40 equals 15.9. All right, so again, we're using that distributive property, right? If there's a number on the outside, make sure that you're distributing it to everything inside. And notice that on this one, we're doing a negative, right? 0.03 that's being distributed through. Okay, so let me give you just try this one out and see what you come up with there when you work that one through. You should come up with a whole number answer on this. There shouldn't be a decimal left in your answer, so just a little hint. Make sure you did it right. Okay, so you should have come up with x equals 10 on that one, right? Distributing those through. If you didn't get x equals 10, look back and see if maybe there was a mistake with a negative or something like that that happened. You know, and remember that all of this stuff that's on the left-hand side, right, you just need to combine those like terms together, right? So the pink ones that I underlined there, right, becomes this, and then the green ones that I underlined became this. Right? And then moving it over. All right, so usually the decimal ones, people usually have a better time with than the fraction ones. But if those are giving you some problems, then, you know, speak up. That's just fine. If you're having an issue with it, somebody else probably had the same exact issue when they worked through it. Okay? All right, let's go through just a couple of words that you need to make sure that you know for the test, right? So remember, sum means addition, right? Difference means subtraction. Product means multiply. And quotient, that weird word, quotient, means divide. All right, so sometimes they're using these words and you just need to make sure, like in a story problem, that you know whether that is talking about add, subtract, multiply, or divide, depending on what you're given there. Okay, so let's look at number 16. Right, so it says the difference of 2 times a number and 6 is 9 more than the number. So remember last time we kind of talked about how it's nice to figure out where the equal sign is in it. And equals is that word is, right? So I'm going to go ahead and write this over here. So for number 16, right, we've got that equal sign there somewhere in the middle. And then all of the words that are on the left side of it are going to be the numbered letters and symbols on the left side of our equation. So let's try and write this out here. So this says the difference, right? So that's something we need to remember. So difference means subtract. So I'm going to put that in here so I know I'm subtracting 2 things. What am I subtracting? I'm subtracting 2 times a number, right? Well, I can call that number n, I could call it x, I could call it q, it doesn't matter, right? I just need to do 2 times some number, so I'll just call it n, so 2n, and then it says and 6, right? So this and sometimes gets confusing because people always think that when it says and, that means multiply, but it doesn't. It refers back to the operation that it said you were doing, right? So 2n minus 6, right, is our equal sign. Now let's look at the other side of the equation. 9 more than the number. Right, so 9 more than is another way to say add, right? So 9 plus the number, right? And the number up here is n. Right? We called it 2n before, but now it's just n. So this is how you set it up. It's just a direct translation, right? You're just like breaking things apart, saying, okay, I'm doing this and this equals this and this. Right? All right, now let's just get our n's on the same side of the equation and our whole numbers on the other side of the equation. So I'm going to subtract my n over here. That will give me n minus 6 equals 9. And then I'll just add 6 over to get n by itself. So n equals 15. So the number that I'm finding on here is 15. And I could check it by putting it back in there, right? But remember that, you know, when you're solving something like this, where you've made your own equation, if your equation that you started off with was wrong, then you can't really check to see if your answer was correct or not. It could be correct for what you wrote as your equation, but if that was incorrect, then to start off with, then you might not end up with the right answer there. Okay. What questions can I answer on that? About just doing some of that direct translation. Okay, what about some of these other ones? Do we want to do, like, practice one that has two consecutive odd integers or even integers, or if we have a rectangular room, or one of the marble ones, or a board is cut into two pieces. Which one of those type of word problems would you like to look at? None of them? Feel like you got all of those down? Come on, guys, speak up.
How about 18?
Okay, let's look at 18. Have to kind of scroll down a little bit here. Have some room to write this. Okay, so remember when we have these consecutive, it doesn't matter if it's consecutive odd or consecutive even, but remember consecutive numbers mean one right after another, right? So if I was talking about some consecutive odd integers, those would be like 1, 3, 5, right? These are the odd integers that are one right after another. But you can tell that you're always adding 2 to get to the next number, right? So if we said this was x, then that means to get to our next number, we'd have to do x plus 2. All right, so that's kind of what we talked about before, is we have this x and this x plus 2, right, would be our consecutive even integers. But we said, okay, the sum of those two things, so x plus 2, is going to equal 92. So is our equal sign and then 92. And then let's just combine our like terms together. So x plus x is 2x plus 2 equals 92. And then we can subtract the 2 over. 2x equals 90. Divide by 2. So x equals 45. But remember, it doesn't want just what x is, right? That's my smallest number. But then what would my next number be on that? Right? So because I'm trying to find two consecutive odd integers. So one answer is 45. What would my other answer be? You can type it in the chat if you want to. And you can even type a private message to me in the chat if you feel nervous about putting the wrong thing in. That's okay. Okay, awesome. Colton said 47. How did you get 47, Colton?
I took the part of the equation like x plus 2, since that's the second number.
Mm-hmm. Yeah, so if this was our x, is our 45, right? X plus 2, right? Take 45, add 2 to it. That gives us that 47. Okay, so 45 and 47 would be our answers on that. Okay, any other ones here? Do you want to look at 20 or 21 or 22? You guys are so quiet today. I want this to be something that's helpful for you, but I don't know what type of things you're struggling with. So, and I know sometimes it's hard to remember back to chapter 1 too. You're like, oh, I don't know, maybe I remember how to do those type of problems, maybe not.
Can we do 20?
Yeah, let's do 20. All right, so 20 says a rectangular room is 3 meters longer than it is wide. right? And its perimeter is 30 meters. Find the dimensions of the room. So we want to know what the length and the width are. Right? So if we draw just a little picture of what's going on here, right? Here is my lovely rectangle, right? And all I know is that one length of my room is 3 meters longer than the other, right? So I don't know how long this is, so I'm just going to call it W. I don't know what my width is, but I know that my length is my width plus 3, right? So the length is 3 meters longer than it is wide, right? Whatever width is, add 3 to it. Okay, and then I know my perimeter is 30, and remember, perimeter is around the outside, right? All the sides added together, right? So if I was to set this up, I would want to add those together. So I don't know what that side is. It's W plus 3, right? This side is W, and I need to know this side, which is another, plus W plus 3, and then the last side is W, right? And that's going to equal 30. So I ran out of room there. All right, but now let's combine our like terms together. So how many W's do we have? 1, 2, 3, 4. So I've got 4W. And then add my whole numbers together. 3 plus 3 is 6. Equals 30. Right? So that's basically the equation I'm trying to solve there. That 4W plus 6 equals 30. I'll do that just down here a little bit. Right, which means I just need to subtract my 6 from both sides. So I get 4W equals 24, and then divide by 4. So W equals 6. Right, so there's one of my answers. Right, but I want to make sure to remember the units on the answers too, right? So I've got, so my width, because that's what my W equals, width is 6 meters. So that's what I was talking about, was in meters. And then what would my length be? So I'm going to just type it into the chat. What would the length be? My width is 6. Yeah, it's just going to be 9 meters, right? Because remember, my width, right, is 6 here. Put this in a different color, right? And so then I'm really just doing 6 plus 3 gives me 9. So those would be my two answers there. Okay, awesome. All right, should we skip down to those variation problems? You do need to make sure that that you remember what the equation looks like if it varies directly or indirectly. Right? Direct variation was y equals k times x, and inversely or indirectly is y equals x over k. Inversely as x. Wait a minute, it's k over x. I think I have that wrong here. It should be k over x. Sorry about that. Okay, and x is on the bottom because it's inversely as x. Okay, x is on the bottom. All right, so, and again, you'll be able to use your notes on this, and so you could look these formulas up, right, when you're working through them. But remember that there's kind of some steps you have to take, right, when you're doing you know, these direct and indirect variation, the first thing that you'll have to do is you'll have to solve for that k, and then after you solve for the k, then you can plug that into the formula that it, you know, gives you there to find that answer, right? So let's double check here. Oops. So let's maybe do 24, right? So y varies inversely as x. So y varies inversely as x. If x equals 2, then y equals 6. So I'm going to just use this first part here, okay, just this, and solve for k. So let's put that in there. So I'm going to put 6 in place of my y, and then k is what I don't know, but I know x is 2. Right? And so to solve for k, right, this is connected, k is connected to 2 by division, so I need to multiply both sides by 2. Right? So I get k equals 12. Right? And a lot of times students will stop there and forget that they've got to do more. Right? We haven't used any of this stuff yet. Here, and this is what we're really trying to find. All right, so now it says find y when x equals 8. So now I know what k is. I know what x is. Now I want to figure out what y is. So again, let's go back to that original equation, right? So y equals k over x. And I'm just going to show here what I'm doing, right? I'm taking my 12, and I'm going to put it in place of k, and I'm taking my 8, and I'm going to put it in place of x, so then I can solve it for y. So y equals 12 over 8, and that reduces, 4 will go into both of those, and so 3/2 would be my answer there. Okay, so on 24, right, so I get there. Questions on that one? How to do those direct or indirect variation problems? All right, let's look at the next page here then. Right, because Chapter 1 definitely had quite a few story problems that we talked about. So what about these type of problems, right? So this top one, so this I guess is still direct variation. We've got some percent problems. We've got one where, you know, you're trying to figure out if you leave an 18% tip, your total bill, right? And then like if you have book, you know, how much, 4%, if you've only read 4% of the book, how many pages is that? Any of those, which number, you just type it into the chat. Any of those, like 25 through 30, or any of those? Okay, 29. 29. All right, so 29 says, at a restaurant, the bill comes up to $79. You decide to leave an 18% tip. How much total will you pay after including the tip? So this one kind of has two parts to it. You first need to figure out how much money is an 18% tip, right? And so a lot of this you can do on your calculator, but I'll just write it out here so you'll know what I'm doing. So I have to take my bill, right, of $79, and I'm going to times it by 0.18, because remember, 18% is the same thing as 0.18, as I'm moving my decimal point 2 places to the left. Okay, So I'm going to multiply that, and actually I'm going to rewrite this. I'm not going to write this multiplication because then it looks like a variable, which I don't want it to look like. So let's just show 79 times 0.18. Right, what do you get there? Go ahead and just type that into the chat. What do you get when you do 79 times 0.18? Okay, yeah, so $14.22. $14.22, right? Now this isn't the total amount, right? Remember back here, what's the total, right? Including the tip. Well, this is just the tip, right? So I'm just going to write that out here just to remind us. So this is the tip amount. Okay, then what would I need to do to find that total amount?
Don't you add them together?
Yeah, we're going to add this, sorry, the 79 plus the 1422, right? Because 79 was what it started off before the tip, right? Then you add that tip to it. So then what does that make your total amount be? Like $93.22, right? That's total paid, right? Including the tip. Right, so it's kind of a two-part thing. We did talk about another way that you could do it, and it kind of saves so you don't have to add that back in. And it doesn't matter to me which way you do it. But remember, you could just do it in a different color here. If you did 79 times 1.18, right, instead of it being 0.18, but if you multiplied it by 1, well, think about if I take 1 and multiply it by 79, that's the 79. And then when I do the 0.18, I get the 1422. So this just combines it all together in one. So try that on your calculator and you'll see 79 times 1.18 will get you right to that answer of 93.22. But sometimes people are getting confused, like why that works, and so they were going this other way, and that's fine too. Like, I just want you to see what works best for your brain, right? But you still will end up with that same answer if this works better for you. To see. Oh my goodness, sorry. I didn't get enough sleep last night, I don't think. Oh man. You guys believe this semester is almost done? We've got this class and then we've got one more after this and then it's going to be the final exam. So, make sure that you're working hard. If you don't have all of your homework and stuff like that done, like all of the reality checks and all of the learning strategies and stuff are still open. And so if you haven't done some of those from the past, please go back and do those. It will help your grade immensely. It can bring you up quite a bit. So, keep that in mind. As something, if you're trying to figure out what could I do to get my grade up a little bit more, that would be a great thing to work on. Okay, and just finishing up all your assignments. Right? Because module 6 stuff, I put a due date on it, but they are still open for you to do. So if you didn't get them completed yet, please, go back in and get those all completed. Okay. All right. There usually is some kind of a question on the final exam, like something here on 1.9, and they'll give you the formula that they want you to use, so maybe they'll do surface area or volume or whatever, but that formula will be given to you, and then you're just plugging in the numbers where they go, right, for the length, width, and height, right, putting those in place of your length, width, and height on there. Okay. But what about one of these? So oftentimes people are good. Okay, I can plug those numbers in, figure out what the answer is. But let's look at 34. Right, this is going to be an important thing to make sure that you know how to do. You're going to do it again in your, in 1010, 1030, maybe a little bit in 1040 too, if that's your next math class. So for this one, we're trying to solve for y. So we're trying to get y by itself. So we need to move that ax part over first. And so it really is just kind of breaking down. A lot of times students get kind of wigged out by these because they're all variables. And they're like, oh, I don't know what to do. But think about what if they were numbers there instead, right? If your a, b, and c were just numbers instead, what would you do? Well, I would start off first. Let me put this here. So this is 34. Right, so I'm thinking, okay, I want to get y by itself, so I'm going to subtract my ax over. So that'll give me by equals c minus ax. And then to get y by itself, it's connected by multiplication, so I just need to divide by b. And so that would be it. C minus ax over b. And if you had it as negative ax plus c over b, that's fine. That would be the same exact answer. Okay. All right. How about this? Do you want to look at 35 or 36? This is kind of one of those ones that has a garden with a walkway around it. Right, and this is finding the area of a strange shape. Okay, so look at 35. Okay. So with 35, let's wonder if I should draw a picture a little bit bigger over here just to make sure. All right, so we've got this garden, and there's this walkway around the garden. And so if you're trying to imagine in your mind some kind of a picture, then just draw that picture out. It'll make it a lot easier for you to solve this. Okay? So on the garden, it says the width is 6 feet and the length is 5 feet. Right? So I'm going to say that this one is 5 feet and this is 6 feet. Actually, let me write it inside. It's a little bit hard to tell which one I'm talking about here. So I'm going to go like this. So I'm going to say the length of this side here is going to be 6 feet. And the length of my other side of the rectangle is going to be 5 feet. Okay, just to make that a little bit more clear. So that means that this one is also 6 feet, and this one is also 5 feet. Right? But then it says it's surrounded by a walkway 3 feet wide. Right? So remember, everywhere on here is 3 feet. So if I'm comparing, like how much longer this side is from the 5, right? Look at, I'm going to have to add 3 feet here. Oops. To do a different color. I'm so sorry. So I'd have to add 3 feet here and 3 feet here. All right. So now this is really 5 plus 3 plus 3. All right. So that whole length is going to now be 11 feet. All right. From here down to here. Right. Okay, and then if I'm looking at my other direction, right, so I've got 6 feet here, but again, this is 3 feet wide, and this is 3 feet wide. So when I'm trying to figure out the length of this whole side, I'm doing 3 plus 6 plus 3, right, which is going to give me 12 feet. All right, so I found these different dimensions, but what do I do now? What should I do now to try and figure out, let's look back to the question, right? What are we trying to find here? We're trying to figure out how many square feet of area does the walkway cover. So I only want to know, right, this part. I'm kind of filled in purple here. Right, what's the area of the walkway? Okay, how will I do that with what I know here? Can somebody unmute themselves and talk?
Would you like add them all together, or would you like times them?
So how do we find area? Do we multiply or do we add? Do you remember?
Multiply.
Yeah, right, so area is multiplied. So if I find the area of the large rectangle, right, that's going to be the 11 times 12, right, which is 132. But then also I want to know the area of the small triangle, or triangle, let's say rectangle, okay, which is 5 times 6, and that's 30. All right, so let's think about this. So if I know the area of the whole thing, right, and I subtract off the area of that small triangle or rectangle, do you see what I would have left is what I kind of squiggled in here in purple. So that means that I need to subtract those from each other. Right? So I'm doing 132 subtract 30, which gives me 102, and make sure you remember your label, right? It's talking about square feet, right? So you can write it as feet squared, or just write it in words as square feet, right? And this is the area of the walkway. Right, so you kind of need to figure out, like, 3 out in each different direction, right? It's going 3, 3, 3. The common mistake I saw on test when there was a question like this on the test is that people were adding 3 to, it just once. So they were doing 3 plus 5 and they'd make this 8, forgetting that we had 3 more over on this other side too, right? There's 3 on both sides. You got to make sure you account for. Right. Questions on that? All right, we are about halfway through class here. Let's get up, take a little break. I really would like some more participation from you guys in here. Really, this is for you, and it's going to be helpful if you can tell me, what things you want to look at more. So, okay, let's start in and review some things for Module 2. Let's look at number 38. So notice there's 3 different directions on here, right? Solve, graph, and give your answer in interval notation. So make sure that you do all of those things. So we're going to first start off. So negative 3x plus 9 is less than 0. So I want to solve it for x. So let's subtract the 9 over first. So it gives me negative 3 is less than negative 9. But now to get x by itself, I need to divide by a negative 3, which makes that inequality sign flip the other way, right? So I'll get x is no longer less than, right? We're going to put it as greater than 3. And so when I plot that on my graph here, right, figure out where 3 is. Say 3 is here, and I want all the stuff that is greater than 3. So I'm going to have an open circle at 3, and then all the stuff right to the right of it. So this arrow, as long as you solve it so that your x is on the left-hand side, then it kind of looks like this is an arrow pointing to the right. And so that would be that. And now we got to write our interval notation. So when it's an open circle, we use a parenthesis because that means it doesn't include it. 3, and then it's going out forever in the positive direction. So that's going to be going out to positive infinity and then parenthesis again. Okay, so there's our different answers. We solved it, we graphed it, we wrote our answer in interval notation. Okay. All right, hopefully that, remembering how to do ones like those. All right, so maybe let's look at number 39 next. This one and 40, you've seen stuff like these on tests in the past, so pretty good, chance that one of these could show up on the final exam. So it'd be good to make sure you know how to do these. Right? So let's look at 39. Sarah's goal to find a job that provides an income of at least $65,000 a year. A company offers her a base salary of $17,000 a year plus a commission of 4% of her sales, whatever she sells. All right? How much money in total sales, right? How much will she have to sell in order to get an income that's greater than or equal to $65,000? Okay, let's break this down into two different parts, right? We've got her base pay plus her commission, right, is going to equal, right, or in this case we want to actually greater than or equal to, right, the $65,000 is what she wants to. She's not going to be unhappy if she makes more than $65,000, right? So we want that greater than or equal to there. Well, what's her base pay? Well, we know her base pay is at $17,000 a year. So put that in here. And then her commission is what we don't know. But notice what our X is going to be on this is her total sales. So we're going to say X, that's what we're trying to find, is her total sales. Right? And so we don't know what her total sales are, but we know that she's going to get 4% of whatever those total sales are. So 4% is the same thing as 0.04, right? Not 0.4, that would be 40%. So 0.04. So we're trying to figure out here, right? So the next part is saying, okay, then what are we going to add to it? Well, whatever her commission is, which is 4% of whatever she sells, right? And then we want these added together to be greater than or equal to 65,000. Right? And of course, on these word problems, usually the setting it up is the toughest part, but break it down a little bit like this, right? So I'll subtract the 17,000 over. And then 0.04x is going to be greater than or equal to 48,000. So really, right, we subtracted that 17,000 off because she's going to get that no matter what. So she's trying to make $48,000 in commission. And so to figure out how much she'll have to sell, we'd have to divide by that 4%. Right. And then when you do that on your calculator, all right, get a pretty big number there. Right, I think it's over $1 million. It's like $1,200,000, right, is what she'd have to sell. Right. So just kind of break these apart, think about, okay, what do I know here? How can I use this information to get to what I need there? All right, a couple of reminders about these and or statements. Remember that we talked about intersection and we talked about union. All right, so intersection is going to be our and statements, and union is going to be our or statements. Right? Remember, intersection is just where they overlap each other. Right? Remember we talked about like an intersection in the road, right? Well, that's where the two roads, like cross over each other. That would be the intersection. And union just means everything, right, that is part of those solutions, right? So if I was talking about, two different roads like Redwood Road and 4700 South or something, right? The intersection is just that intersection, but the union would be all of Redwood Road and all of 4700 South, right? So it's everything in both of those sets. So that's what our or is talking about. So let's try a couple of these. Let's do maybe one and statement and one or statement so you can see what happens on these. So let's look at, well, let's do 43, the one with the fraction, just because that tends to freak people out more. Remember, and you can go back, and the ones that we didn't do, I would still suggest you go through them on your own. And then you can check your answers because you have the answer key too. At least it gives you the answers, not like the solution of how to get there, but you can check your answers. Okay, so in this one, oops, number 43. All right, so we're going to solve these two things just separate from each other. So it's like we have two separate things that we're solving, right? So here I'm going to subtract my 2 over. So I get negative 2/3 x is greater than or equal to 3. But then to get my x by itself, right, I need to multiply by the reciprocal. So I'm going to be multiplying this by a negative 3/2, right? I'm just flipping it. Right? And that means I need to multiply this side by negative 3/2. So that's going to get rid of everything here, right? My 3's divide out, my 2's divide out, negative times a negative is a positive, so I'm just left with x on this side. But I multiplied by a negative number, so that's going to make this inequality flip the other way. So I get x is less than or equal to, and then I'm just going to multiply across the top, multiply across the bottom, and that will give me negative 9/2. Okay. And then here, this one's not as involved, right? Just need to divide by 5 to get x by itself. So x is going to be greater than -1. And I didn't flip this one because I wasn't dividing or multiplying by a negative number, right? This was a positive number there. All right, let's put both of these on there. Well, first of all, where is negative 9/2? All right, that's the same as negative 4.5. So if that's easier for you to figure out where it's on the graph. All right, so here's my negative 9/2, and here's my -1. All right, you could write it down as negative 4.5. But then, got to notice our signs, right? So since this has the equal to part, right, then that means that's going to be a closed-in circle there, right, by my 9/2. Where on my other one, right, let's see, by my 1, that's going to be an open circle there. Okay. And then you've got to follow this and just kind of see where these end up. Well, this is saying everything less than or equal to negative 9/2. So that's all the stuff to the left of it. And then this is saying all the stuff bigger than negative 1. So all the stuff to the right here. Okay, so both parts of that are part of my answer because notice this is an or statement. Okay. And then I have to write that still in interval notation. Right? So I'm going to write, just try and write it over here. So negative infinity to negative 9/2. Right? And then union, you got to use that little union symbol because we've got this part of our graph, but also this part. Right, whoops, that should be a squared bracket there. Right? Because it's a closed-in circle, it includes it. But then we've got an open circle, so in parentheses at negative 1 to infinity. All right, what can I help you understand better on this one, on 43? Now, there's a lot to it, and it's been a while since we've done those, so let me know what I can help clarify. All right, I'm just going to have you guys try one of these. So let's try number 45. I want you guys to get it started. See what you can do with 45. But notice it's an and statement this time. Okay, I'm going to give you a few minutes. Use this time, solve those down, and then think about what you need to do because it's an and statement. Okay, make sure you do all of these things too. Solve, graph, and write your answer in interval notation. Okay. When you get all those done, you use the little hand raise button and show me, like just raise your hand when you have an answer on 45. Okay, so hopefully this is what you kind of came up with here. So you got x is less than 3. Remember that you needed to flip that inequality sign because you divided by -4. And then your other answer was x is less than or equal to 4. And so if I plot that out, right, this is how it looks. Okay, but how would I write this in interval notation? So I want everybody to write in the chat box. What do you think that would be? How would we write our answer of this in interval notation? Don't hit enter quite yet. If you want to send it to me privately, you can too. Okay, but I want you to try and put in the answer to this in interval notation. Okay, let's see what you guys come up with. So 3, 2, 1, hit enter. Okay, so we did come up with a few different answers, and this happens a lot because it gets kind of confusing trying to remember what we're doing. But remember, this is an and statement, right? So if it's an and, we want just where it's overlapping. So the only place where this graph is overlapping, right, can you see it's from here and over. So that means our interval notation would need to be -infinity to 3 to +3, right? And then remember, there's no overlap. That, because it didn't include the 3 before, so that point isn't overlapped. So that would be a parenthesis there also. Okay. Okay. And it has been a while, Jordan. Thank you. I bet you're not alone on that. And just remembering all these little things like flipping the sign, or remembering that when it's and, we want just, the overlap part. Okay, what other things can I clarify on that? Does everybody see why it's -infinity to 3?
I thought it would be to the 4 since it included the 4, but now I know that it's just the overlap.
Yeah. Okay, good. I'm glad you can see that. And I think a lot of people do that because they think, oh yeah. But if it said or here instead, then that would be everything, right? So if it was an or statement, I'm going to just write that underneath here. If it was an or statement, then our answer would mean everything in both of our solutions. So then that would be from -infinity to 4. Right? So it's really important to watch the and or statements on those and just kind of remembering what that means. And draw your graph and just think, okay, yeah, where is it overlapping? Awesome. Okay, let's look at, well, maybe we should do one with these compound inequalities. They're really not that different, but sometimes it's, kind of freaks people out of what you need to do there. So let's see, maybe let's do 46. So when I'm solving these, I'm trying to solve for it to get x by itself in the middle, right? So these are and statements just because they can be written together as one statement. So anytime we have, right, these 3 different parts, the tripartite, right, then it's always going to be an and statement. It can't be an or statement because all we can figure out is where the overlap is when it's written like this. Okay, so I'll have -13 is less than 4x minus 1, which is less than 7. So I'm trying to get x by itself in the middle, so I'm going to add 1 here. And if I add 1 here to get rid of it, then I have to add 1 to the left side there, right, to that negative 13, and also add 1 here. And so, again, when this showed up on quizzes and tests, I saw a lot of people missing it because they were forgetting that you needed to add it to all 3 parts, right? We do it there in the middle, so we can see that's gone. We're getting rid of it, right? But then we still have to add it to those other parts. All right, so that gives me negative 12 is less than 4x, which is less than 8. And then to get the x by itself in the middle, I need to still divide by 4, right? So that gets 4 divided by 4 is 1, so I'm just left with a 1x in the middle, which is what I'm trying to do. But if I divide by 4 here, I've got to divide by 4 in all of the places, right? So negative 12 divided by 4 is negative 3, which is less than x, which is less than 2. Okay. Or remember the other way that we can read this, like we can read it as negative 3 is less than x, which is less than 2, but that doesn't really kind of help you in your brain, like visualize what's happening, right? You can read this as x is between, right? It's literally between negative 3 and 2. So if I was graphing this, right, so here's my negative 3, here's my 2, x is all this stuff between 3 and 2. And notice that both of these are open circles because it doesn't have the equal to part. So I'll put an open circle here, an open circle here, and then I just want the stuff in between there. And so then interval notation on that would be parenthesis, negative 3, comma 2, parenthesis. Questions on that one? All right. Well, I want to get to talking about the absolute value equations and absolute value inequalities. And remember with our absolute value equations, we're solving those. Well, maybe back up a little bit here. Remember, if I'm trying to figure out what the absolute value of x is, right? It says the absolute value of x equals 3. Do you see that x could either equal 3 or x could equal negative 3? Right? Because if I put 3 inside my absolute value, I get 3. If I put negative 3 inside my absolute value, I get a 3 also. All right, so let's look at number 48. So you have to remember with these absolute value equations that you have to make the 2 separate equations that you're going to be solving. Right? So it says the absolute value of x plus 5 equals 10. So I'll write my 2 equations. My first one is just going to be x plus 5 equals 10, right? Just how it was without the absolute value. But then the second one, we need to make one side of the equation negative because I need to look at that other, possible option there of something negative. The absolute value of a negative number will still give us that. All right, so I'll have x plus 5 equals negative 10. And so now these are our 2 equations that we need to solve. So I'll subtract 5 over, x equals 5, and then subtract 5 over here, so x equals negative 15. And so you get 2 answers on these. Okay? That's what you got to remember with these absolute value equations. You should get these 2 different answers. Okay, and remember, just like you would do on the quiz, usually they just, give you a little box. They'd say like x equals, and they give you a box and you just put 5 comma negative 15 to say that there were 2 answers there. Okay, that's oftentimes the way they did it. Right? And this will look really similar to your, like I said, your online quizzes, right? The ones that you do on Canvas. All right, let's look at some now with the absolute value inequality, because those tend to be the trickier ones, because we've got to remember whether we're talking about an and statement or an or statement. So we know, do we want the intersection, right, just the parts that overlap, or do we want all of the parts? Do we want the union? So we came up, right, with a funny little thing to help us remember. So remember, if we have this symbol, right, this is a gray tour. So we're going to be doing an or statement, right? And it could be the greater than or equal to, right? So if it's either of those two, right? But if it's going the other direction, I'm going to put it up here. So if we have a less than or equal to or a less than, then we said we call that less than. Right? It's an and statement. Right? With and statements, we want the intersection. With or statements, we want the union. Okay? Kind of like we said above here. So let's look at a few of these. Let's do let's do number, I'm going to do one of each of them here. So let's do number 50, right, and see what happens here. So again, you still have to write your two different statements out, right? So we're going to have one of them as 2x minus 1 is greater than -5, right? And then we're going to have our other one as 2x minus 1 is less than 5. So remember, we have to flip the sign, right, flip the inequality, I'll say it that way, flip the inequality and then change the sign of that number. Okay, so you've got to remember to do both of those things. And then we'll solve it out, just like we did here on 48, right? So let's add the 1 over. So I get 2x is greater than -4. So x is greater than -2. And then let's solve the other one. Let's add 1 over. 2x is less than 6. Divide by 2. X is less than 3. All right, so if I put that on the number line here, let's see what happens. Let me choose two different colors here again. So you can see which one I'm talking about when, you know, which one. So x is greater than -2. It's going to not include -2, but be all the stuff greater than it, all the stuff to the right. Okay. And then this orange part, x is less than 3. So again, I got an open circle here. But then I want all the stuff that's less than 3. Okay. Okay, so now I want you to think here, right? Look at your sign at the beginning. Right? This little symbol right here is telling you a lot about it. Right? So do we have an or statement or an and statement? Write it into your chat box. I think that's an or statement or an and statement. And then go ahead and hit enter so I can see. Okay, awesome. So it's or. So that means that we want everything, right? We don't want just the overlap. So on one like this, I have a lot of students think that it's between -2 and 3. Well, that would be the case if it was an and statement, because remember, and just wants the overlap. But this is everywhere both of these graphs occur. And so do you see how it's everything? Like it goes, you know, out in both directions, right? From -infinity to +infinity. It's going to span everything. So our answer on this is -infinity to +infinity, right? Or all real numbers, something like that. Okay, and you could have seen this right from the start, but a lot of times people kind of get caught up in how to do it and forget that they could kind of look at something. But think about this, right? If we take the absolute value of some number, right, that's always going to be positive, right? Well, when is a positive bigger than a negative? It's always bigger. So that's how we kind of know that it's going to be these all real numbers, because everything's going to work, right? Positive would always be bigger than a negative. Okay, but if that's kind of confusing to you, you can just work it out like we did here, and then just remember to graph it, and then we want everything because it's an or statement. Okay, on this other one, let's look at 52 now, right? So in 52, we've got an and statement, right? We've got this less than. Right. So we've got an and statement here, so we've got to keep that in mind when we're solving it through. Right. Okay, so I want to have you guys write out the two different statements that you're going to be solving, and then go ahead and try solving it. Mm-hmm. Okay, so this is usually kind of the tricky part. You can get down to here, and then you got to make sure that you have, so I want you to write your answer in interval notation. Put it into the chat box. Don't hit enter yet, but put into the chat box what you came up with for your answer. See what you have. 3, 2, 1, hit enter. Okay, awesome. This did great. All right, so since this was the and statement, right, then we want the overlap. So we want just the stuff where it's overlapping, which is going to include 2/3 and also include 2. So it should look just like that. Right? If that was going the other way, it was a greater than or equal to, well, then we'd have the same situation that we had going on above, right? Where it would be all real numbers. So that little sign is going to totally change your answer. So you got to remember that whether it's an and statement or an or statement on these type of things. Okay? Okay, let's look at 54. So I'm talking about domain and range. Remember that the domain is the set of all x values. I'm just going to actually write that on here, right? So these are going to be our x values. And the range is our y values. And so if we're given just 4 points like this and asked to find the domain of it, well, we just list down what our x values are. We've got 8, 7, 6, 5. Okay. And then our y values would be all 2's, right? But we only have to write that down once if it's 2 all the way across. Okay, and now we're trying to figure out, is this a function or not? Right? So remember that with functions, we said that our x coordinates need to be unique, which they are. They're all different. They're all going to the same y, but that's okay, right? So our y's can repeat, but our x's can't repeat. Okay, so I'm going to say yes, it is, because x values don't repeat. Okay. So if there were some repeats in the x values, then it would not be a function, right? And so if I looked at just the one above it, right here, right, all of our x's this time are -6, and they don't all have to be -6 or like all the same number. I could have had, you know, if -6 just showed up in just one other point, then it would not be a function. Okay. All right, so to find the domain of the function, so these are functions that don't just have like 4 points to them. They've got infinite amount of points to them. And so we've got to be able to say, you know, what would all of the x values be? Or it's what we're trying to figure out for the domain. So remember on ones like 55, when we're trying to find the domain of something that's a fraction, right? We're going to set that bottom part equal to 0, and that's what we're going to say it can't be, right? Because it can't equal 0. So if I subtract the 4 over, then I'm saying x cannot be -4. It can be any other number, just not -4, because -4, if we put -4 down there in place of x, -4 plus 4 gives me 0. I can't do 1 divided by 0. That's undefined. So that's what we're trying to figure out here. So this is what doesn't work, right? But it wants your answer in interval notation. I'm going to just draw a little, you know, picture of what this is saying too. So at -4, all right, we basically kind of have a hole in the graph there, right? It can't be -4, but it can be everything to the left of it and everything to the right of it. So in interval notation, that would be -infinity to -4, not including -4, union, parenthesis, -4, right, because it doesn't include the -4, to positive infinity. So this is how we write that in interval notation, right? That says you can have any x, just not 4, or -4. in this case. Okay, on 56, right, so now there's one other type that we talked about. What if we have square roots? Well, again, remember with square roots, we can't take the square root of a negative number. So that means that the stuff inside the square root has to be positive. Okay. So you're going to set whatever's on the inside, right? So I'm going to say inside of square root greater than or equal to 0. Because if something's greater than 0, then it's positive. And we want to know what the positive values would be. Because we can't use any, like that whole thing inside there, once it simplifies, it can't be a negative number. It has to be a positive number. All right, so I'm going to take that 2x minus 1, whatever's on the inside, and have it greater than or equal to 0. And then I'll solve from there. So I'll add the 1 over, and then I'll divide by 2. So x has to be everything greater than or equal to 1/2. Right, so it can include 1/2. Right, it can include 1, it can include 2, it can include 3, right? But it can't include 0, right? Because that's less than 1/2. It can't include -1. Right? We need all of our x's have to be greater than or equal to 1/2. So if we write that in interval notation, right, that would be 1/2 to infinity. Because we only want the numbers that are 1/2 or bigger. Okay. So domain like that. And this was number 56. Back over this and see that. All right, are you remembering that with these domains and stuff? Those are the only two exceptions. Usually, like with any kind of function, we'll just say it's all real numbers. You can choose any negative number, any positive number. But if there's a denominator that has a variable in it, then there's a possibility that we could divide by 0. And we can't divide by 0, so we can't let our x be that. And then we can't have negatives inside the square root. So we want to know what is positive, or what's non-negative, I should say, because it can equal 0. Just, right? Can't have the negative numbers. All right, let's do this one last one. Oh, I guess we can't. We are out of time already. All right, well, we will stop there then. But we got through Module 1 and Module 2, and those are usually the fuzziest in people's brains on what they, remember and stuff. So it's good that we made it through most of that. So if you have any other questions, let me know. Make sure you're completing all of your homework, getting that all done. I'm working on that this week because there's no other new homework. You just need to get everything done up through 5.8 was our very last, or sorry, 5.8, 6.8 was our very last section that you need to make sure that you do, and make sure you have the reality checks done and learning strategies. Now, there wasn't a learning strategy for Module 6, okay, but there is a reality check, so make sure you get that done. All right, if you have any individual questions, stay on and you can talk to me. Otherwise, I will see you guys on Thursday and we'll review more.